Ready? Right, triangulation. So what we're looking at is when there's more than one situation where there's multiple triangles happening at the same time. Okay? So triangulation should be used when the distance between two locations is given. The last exercise we did when we talked about the compass bearings. So a ship sailed from one point to another point, changed directions, went to another point, and then it returned back where it came from. That's triangulation. It's created a triangle for you to do some maths with. The distance from each of these two locations to a third inaccessible location is known, and that's when you have to do your maths. So for triangulation, the sine rule is used to find the distances from the known locations to the inaccessible one. So, you know some information here, you can find the distance to the third. Okay? So use the sine rule. The cosine rule may be used occasionally for locating a fourth inaccessible location. So to find out a completely new location that you don't have any information for. Okay? That's what we're using now. So, this is straight from your textbook. So hopefully you guys will refer to that later on. Page 374, question 7. The student surveys her school grounds and makes the necessary measurements to 3 key locations as shown in the diagram. So she's got a kiosk, toilet, and her office. Alright? We also have a location A and B as an intersecting path that she can reach. So, we're going to find the distance to the kiosk from point A and from point B, then to the toilet for the same 2 locations. Then we're going to find the distance between the kiosk and the toilet. There's no path there currently, but we need to find one. Then we're going to find the distance from the office to location A. Alright, so let's work through it. For A, we're looking for the distance from the kiosk to location A. So we're looking for this distance here. Do you want me to redraw the triangles as we go? Yeah. Thank you for answering. Okay, so what we're looking for is from here to here. Can you see the triangle that you would use? Okay, so where is it? Middle? That one? That little one? That's going to help you get to the kiosk?
No, you're going to use from kiosk to A to B to kiosk.
So, you're going to create a triangle that goes from A to the kiosk to B. Do you see that big triangle?
Yeah.
So, we're going to use the triangle. I'm going to abbreviate everything. A, K, B. From A to the kiosk to B.
Could you also get the side from A? You see A there, that one. You can also get that side there.
To this point here.
Yeah.
Why would you bother doing double the work
Yeah,
to find that one when you can just work with one big one?
Yeah, right.
We're looking for shortcuts that are going to give us the right answer.
Yeah.
So, using this new triangle that we have drawn, it's not to scale. B, A, and our kiosk. What's this angle here? What's the angle for A? No. 100. The 100 goes from the outside to here. 60 only goes from this line here. Okay, so we've got 100 degrees. What's this angle here for B? 30. Straight from in there, we've got 30 degrees. 110 goes out to the second line. And then, what else do I know?
50 metres.
50 metres across the base from A to B.
Yeah.
Which side are we looking for?
The hypotenuse.
No, your hypotenuse are for right angle
A
triangles.
to K.
A to K.
We're looking for A to K. This is the length we're looking for here.
What was the same hypotenuse?
So, automatically, you're going to use the sine rule. What's the sine rule?
Opposite over.
No, that's for the ratios for right angle triangles.
What's this, the sine
This
rule?
is not a right angle triangle.
The sine rule is, we'll use,
Sine A. No, A on sine
A over the sine the angle A is equal to B over the sine of B. Now, you've got a side here with a 50. You have two angles. So, this would mean if we put it in matching little letters for the sides matching the angles, A is here, this is B, and this would be K, a little k. So, do you have enough information?
No.
What's missing?
No, we do have enough information.
Oh, no, we don't.
You
We
can't
don't
use
have
A.
We don't have A.
You can't use A. Do you want to use A?
Yeah.
Yeah.
No. What do you want to use A for? Well, I'm not interested in the distance from K to B. I'm only interested in the distance from A to K at this stage. So if I'm looking for this side, I need this angle. If I've got this side, I need this angle. Can you find it?
Yes.
What is it?
It's 100 plus 30.
It's 7.
And 180 minus 100 minus 30.
So 100. So 180 minus 100 is 80. Minus 30 is 50. Meaning that this is actually 50 degrees. So we've got a K. We've got some B's. So we're looking at K over the sine of K is equal to B over the sine of B. Just to keep the letters matching what we have here. So K is 50 meters. Sine of K. The sine K is now 50, which is equal to B, which is our X, over the sine of B, which is 30. How do I get the X by itself?
Times both sides by sine 30.
Times both sides by the sine of 30.
Thank you.
So, dividing, multiplying, cancels out. So we end up with our distance x is going to be the sine of 30 times 50 over the sine of 50. Into your trusty calculator, and what do you get?
Okay.
I'll work it out for you.
I'm doing it.
Is this process here okay for everyone? Just while I'm waiting? Good job.
32.64.
32.64 meters.
Hang on, I've got 0.37.
James, is your calculator in degrees?
Yeah, I didn't do inverse.
Why are you doing inverse?
I didn't do inverse.
You don't. You shouldn't do inverse.
I just wrote it exactly like that. Sine 40 times 50. Or is that sine 40 just on top and then all of that over sine 50?
Oh, yeah, I got it now. I put it in brackets.
Okay.
Is that right?
I believe so. Alright, so the distance, excuse me, the distance from A to B is now 32.64 meters. And that's from our workings out that we just did. So now, I'm going to fit it in here, sort of. That was part 1. Part 2 says the location B. So to the kiosk from B. So now we're looking for this distance from B to K. Do you have all the information in the triangle already? Yes. Alright, so rather than redrawing it all out, you've already got it. You don't need to look anywhere else. Just put it straight in. So we're going to use, for the length from K to B, we want this length of A. This is what we're now looking for. I'm going to call it Y so we don't get confused between the letters. I'm looking for this. So I've got this length of A, which gives me angle A. So I'm going to use A over the sine of A is equal to, if I'm using that side, which information would I use?
You use A.
Would you end up using the B or would you use the K?
You use A over sine A.
Either.
Yeah, A over sine I've already got up there. What else would I
And
use?
then you can use either K or B. Doesn't matter.
I would use K.
No,
I would use K because K is information you were giving at the beginning.
Sorry, everything needs tissues.
Oh, I'm in the video now.
Yeah. Okay. So I would use K because I'm given information for K. Don't go using information you've created. And I only say that to you because
We've rounded it. It's not whole.
it's not whole. If we've made a mistake, we're going to carry that mistake the whole way through and we don't want to do that.
So, in that case, you don't use Pythagoras. You don't use.
Pythagoras is only used for right angle triangles.
Oh.
We are not dealing with right angle triangles. Don't even go anywhere near Pythagoras. Alright, so A over the sine of A. I'm going to use K over the sine of K. A over the sine of A. A is now Y. Sine of 100 degrees is equal to K, which happens to be 50, over the sine of 50 degrees. So, how do I get Y by itself? Times it by the sine of 100. We end up with Y is equal to 50 over the sine of 50 times by the sine of 100.
You get 64.278.
64.278, we'll go with 28 meters. So, to go from this point B here up to the kiosk, it's 64.28 meters. So I'll write that ends up here. 64.28 meters.
So what's that? Is that from the K of point B?
Yes. Now, I'm going to rub this off so that we can do the rest of the calculations because I've sort of squished it up a bit too much here. Alright, so B. B. B is now asking for the distance to the toilet from location A. So I want to go from here up to the toilet. So can you see the triangle that I'm going to use?
TAB. Comes actually better.
Go from
TAB.
to the toilet, down to B, back to A.
Using the triangle TAB.
So using the triangle.
That's in TAB.
Oh, Jenkins. So this is my triangle. What is the angle of A?
60.
What is the angle of B?
110. That would leave the other one to be 110, 60, 70, 10.
10 degrees.
Yeah, why can't you walk through space with us?
Not allowed to walk on the grass.
Stick to the paths.
So the distance here is 50 meters again.
Yes.
Again, we've got
So I want to find the distance from location A to the toilet. So I'm looking from here to here. So this is my length.
Means the screen's on black.
That's right. It's all right. Now
So we're going to use, we'll use sine.
we're going to use the sine rule again. We'll match the sides to the angles. So angle A opposite is here.
No, I'm not going to do that.
Angle B, the opposite is here. And angle T, the opposite is here. So of the sides, which do you want to use?
T over sine T
T over sine T,
is equal to B over sine B.
B over the sine of B.
And that's going to give you
You've got your information, substitute it in.
50 over sine
T.
10 is equal to
X over the sine of 110 degrees. How do I get the X by itself?
times by sine 110.
Times it by sine of 110.
Good, I'll work it out.
So
So those two cancel out again. X is equal to the sine of 110 times 50 over the sine of 10. What do you get?
you get 110 over sine 50 over sine. 270.57.
Is everyone in agreement with that? Yeah? Okay, so now we found the distance here to be 270.57 meters.
That's right, please, the scale.
So obviously you can see that my diagram is completely out of whack to how it should be. But that's okay because it's just a drawing, it's not to scale. Now, that was part 1. Part 2 says from location B to the toilet. So we're looking from here to here now. So from B to T, so we'll call it Y. So we have another side to work with. And what's the sine rule that you're going to use this time?
Instead of B, we're going to use A.
So we've got A
So it's still T
over the sine of A and T over the sine of T. Substitute your values straight in. So this is just the same thing again. Y over the sine of 60 is equal to 50 over the sine of 10. Get y by itself, multiply both sides by the sine of 60. So they cancel out. Y is equal to 50 over the sine of 10 times the sine 60. What do you get?
You get weighting 60 over 50 over 10. Oh, what? How do you undo? Undo. Oh,
Okay. While we're waiting. What's C?
249.36.
Y is equal to 249.36 meters. Right. So now, you've just found the distance from B to the toilet. And we've got it as 249.36 meters. Yes?
If we ask a question like this from the start, how much marks would we work?
Oh, wow.
Many.
I reckon 6 marks.
Probably 5 and 5.
This question in total, as in the A, B, C, and the D, probably in total would be worth 6 or 8 marks.
Yes.
So a question like this, really, you would expect 1 mark because it is so repetitive and you've had lots of practice. So, and you're going to do it on your calculator anyway. So really, you should be able to see what you need to do, know the formula, which you've been given anyway, substitute it in and just get your answer. It's no longer a case of you will get multiple marks for all the steps, okay?
Isn't it because he's trying to burst?
C. Find the distance from the toilet to the kiosk.
So we're going to have to...
We're now
You're going to have to better line.
looking at going from here to here.
That's really straight.
Man, I thought my lines were bad.
Look, I'm a mathematician, not an artist.
Still, that's much better.
We are looking, going from the toilet to the kiosk. And what's that distance?
X.
Do you have information that you're able to take out from what you have done to find what this distance would be?
No.
Can you create a triangle?
Yes.
Yes, we can. How do you want to create the triangle? Where do you want to go from and to?
To AKT.
AKT, alright, so let's go. We're creating a triangle that goes from A to K to T. So it's going to look something like this.
Can't you go in the center?
I thought 4. No, you can't. You don't have those values.
What information do you know about A, K, and T and those distances to be able to make a triangle?
When
The
they
angle of A is 40.
Sorry, what was that?
The angle of A is 40.
Angle of A is 40 for this angle here.
Yeah, but we're cutting off halfway.
Because it's 100 degrees, we're taking off the 60, we're left with 40. What else do you know?
KKA.
Do you know a distance from the kiosk to A?
Yeah, of course we do.
The distance from kiosk to A is 32.64 meters. Do you know a distance from A to the toilet?
Yeah.
What's A to the toilet?
270.57. Hang on, how is A to T 40? You meant 60.
And Miss, do you know that?
Now, just to confirm, excuse me, just to confirm what's just happened. I'll use a blue marker so it stands out. We are now looking at here. This is the triangle that we are using. That is the triangle that we are using. So we know that this angle here that we want to include is made from this 100 degrees, which goes from here right across to here. If we know that it's only 60 degrees for this point, the rest of it has to be the 40 degrees.
Crazy.
So we have a measurement for here, we have a measurement for here, and we have an angle. We want to know how far it is from the kiosk to the toilet. What information have you got? You've got 3 sides, 1 angle. Which rule uses 3 sides and 1 angle? Cosine rule. So the cosine rule is a squared is equal to b squared plus c squared minus 2bc times the cos of a. That's the cos rule. And you just modify it to match a triangle based on the sides and the angles to match the letters. So if you have this and you know it, you have your sides, you can match it. Angle T, which side is the measurement for T? The 32.64 meters. That's my little t. If this is my angle K, which is the side? The 270.57, sorry, that's your little k. If I've got the angle 40, which side is A? The x. So now I have enough information to fill in to my formula. So I'll just swap B's for K's and C's for T's.
Is there any particular way you're meant to do that, or
Do
you
it
just...
in any order.
Whatever you're comfortable with. As long as the unknown side is equal to everything with its matching angle. Okay? So we have x squared is equal to b, which I'm swapping for a k. So 270.57 squared plus c, which is 32.64 squared, minus, now I have to write it underneath, I'm sorry, take away 2 times b, which is going to be my k, 57, times c, which is going to be 32.64 times the cos of 40 degrees. Now you put that all into your trusty calculator in the right places, and what do you get?
Good number. Oh, I just lost it.
So you pop that in.
Squared plus 32.64 squared. Is it minus
Yeah.
2 times 270.57 what times 32.64 times the 40. 60,000.
Really?
60,000.
So you got
60,742.
60,000.
99.
No, not probably from your calculator. Right, so you do all that workings out, you get this measurement, x squared is equal to that. So you've got to take the square root. X is equal to, James, can you take the square root?
X equals 246.46 meters.
Okay,
So-
you can.
Yep, sorry.
So you can skip a step and just go solve comma x. Does that work out?
You can use solve. If you want to put this in, the only mistake is the other day I was doing this with someone and they actually forgot to put the x squared equals in. So make sure that if you're going to enter this into your calculator and use the solve function, make sure that you actually put the whole line in with the solve and the comma x to say you're looking for the x, or the y, or the z, or the w, or the a, whatever letter you've used. Okay? So make sure you include that whole line in, or else it will not work, it will come up with no solution, and then you'll freak out because you've obviously done everything wrong, which is not the case. It's one little thing you've missed. Okay? Alright, so now we know what C is. So the distance from the toilet to the kiosk is 246 meters. 246 meters and 46 or 0.46, sorry.
What's the distance from?
Now, find the distance from the office to location A. You want to go from here to here.
A over B.
Now, I'm not going to touch a calculator to get this answer. And I'm not going to use a formula to get this answer. Why?
Because it has the same angle.
Has the same angles. If it has the same angles, it's got a matching pair of angles. What kind of a triangle has a matching pair of angles?
Isosceles, like
An isosceles triangle. You need to be able to look at a triangle now and say it's an isosceles, it's an equilateral. If all the degrees are 60, automatically it's an equilateral. You don't even have to think about it. The side's going to be exactly the same. This is an isosceles triangle. The two angles are the same. Therefore, these sides are also the same. The angles that are opposite the sides are exactly the same.
So why do you touch
Which
the
means that this base here is the longest length. Now, what can I do that's quick and easy?
ambiguous case?
No.
no.
I'm sorry, Taylor.
You can't do
I'm gonna play you that back in 5 minutes. What are you gonna do?
Special triangle.
Special triangle.
What a right angle, two equal sides. Oh, you have to use special. I provide the formula like
Right.
Do this with pen.
What?
No, the other one. Yeah, let's go.
Link it.
Yeah.
Why?
Let's do it. So I'll do that. So, because I know we just feel like. Yeah, it's over there, yeah? It's over there. That's why you stick to sports.
Right. So, it's an isosceles triangle. The angles are the same. These sides are going to be the same. The special case only applies when it is a right angle triangle. Is this a right angle triangle? No. So you need to use a sine.
So
Okay?
you said I'm not going to use any calculation.
I'm not going to do any calculations yet.
I'm going to use the sine.
What's this angle here?
80. Oh, yeah.
Haven't done any calculations yet. What sides are you going to use?
Well, you have
You want to find the distance from office to A, so you're looking for here.
That's going to be X. So you're going to use B and O.
B,
And O.
where'd you get O from?
Office.
Office, sorry, I apologise.
Where'd you get U from?
B and O.
Where'd you get U from?
So, for part D, I'll squish it in down here. You've got little b, you've got little o, and you've got, well, you got everything you need now. So that means that it's o over the sine of o is equal to b over the sine of b. 50 over the sine of 80 is equal to x over the sine of 50. X is going to be equal to, I'm going to skip a step.
Yeah.
Sine of 50 times 50 over the sine of 80. And you get the distance to be.
Without a calculator.
No, with a calculator this time. Smarty pants. X is equal to
38.9.
So, from the office to the point A is 38.9 meters.
Actually, no, 89.
8.9.
89. Drowned it. I read it wrong.
Right.
I'm trying to use calculator.
You've done everything. Question complete. On a stack, 8 marks.
But that's a long time.
If I go back and review it, 1, 2, 3, 4, 5, 6,
I think that's worth more than
7 marks. I
That's a
give you for
10
that.
mark question,
That's
isn't
at
it?
least 10.
Because that's a lot of work.
7 marks. It's not, because you can put it straight into your calculator and get one answer. You don't actually have to show any workings out other than you're going to use the rule.
That's my rule.
So really, there is no point in awarding you marks when you're going to put it straight in your calculator anyway. Done. Thanks for watching.